Hi everyone, this is Adam again. So today I'm going to go over some trigonometric proofs that I think typically come up in the papers. So certain things like that. Okay, so things that you can be asked to prove. So and there'll also be more stuff, but basically, the very first one is proving that cos squared A plus sine squared A is equal to 1. So this is basically if you do cos squared of an angle plus the sine squared of the same angle, you get 1. This is specifically back to the unit circle. So remember, this length is 1. If this is angle A, this is sine A, this is cos A. So if we just do Pythagoras on this, we get that sine squared A plus cos squared A is equal to 1 squared, which is 1. So that's how you would prove that sine squared plus cos squared is equal to 1. Okay? Alright, so the next one then is, so we have, the next two forms are the sine rule and the cosine rule. Now, I've never seen these come up. Okay, so obviously they'll be in your book. If you want to go over them, you can. I personally haven't seen them come up. Now, it's very important that you know them. Okay, so basically, if we have any triangle, like this, say this is angle A and the opposite side is A, this is angle B and the opposite side is B, and this is angle C and the opposite side is C. Basically, what the sine rule tells you, that the sine of A divided by A is the same as the sine of B divided by B is just going to be the sine of C divided by C. So all the ratios stay the same. Okay, and in your book, these two things might be flipped, and that's also fine. So it's just that the sine of the angle divided by the length of the opposite side is just a constant. That's all, and it's just the same thing for all three cases. Okay. The cosine rule, however, is a little bit different. Let's say you have something like this, where this is A, this is A, this is B, and this is C. The cosine rule basically says that A squared is going to be B squared plus C squared minus 2BC cos A. So if you think about it, if A is equal to 90, then the cos of 90 is 0. So we just get that A squared equals B squared plus C squared. So we just end up with Pythagoras again. So this is just kind of like a general Pythagorean theorem, basically. So here's your sine rule. Down here is the cosine rule. So the way you think about it is the best way. Typically, there's only like 6 things when it comes to triangles and trigonometry that you can use. You have sine, cos, tan, Pythagoras, cosine rule, sine rule. So there's 6 things. And that's kind of it. So then you sit there and you say, okay, is my triangle right angled or not? If it is, then you can use all 6 of them. If it isn't, then you can only use the sine rule and the cosine rule. Okay? So that's what I'm going to do in the next few questions, okay? So let's just do a couple of examples. So it might be something like this. So solve. So here's 60, this is 5, this is 12, and then basically what they want you to do, they want you to find all of the missing values. Okay? So, first things first. Can I use the sine rule? Yes, I can. I can say, well, the sine rule is going to be, if I use this and this, and this and this, I can say, okay, so the sine of 60 divided by the 12 has to be equal to the sine of y divided by 5. The sine of 60 is a half. So this becomes 5 over 24 is equal to the sine of y. So y is going to be sine minus 1 of 5 over 24. So y is going to be, I'm just going to grab my calculator. Okay, so I have it, it's shift sine 5 over 24. So we get that it's going to be 12 degrees, roughly. So now, to find z, I can say, well, I have 60, I have the 12, so I'm just going to figure out what z is. So I can say z plus 60 plus 12 has to be 180. So z is going to be 108 degrees. Okay? All right. Now, I could use the sine rule again if I wanted to. I'm not going to. I'm going to use the cosine rule just because I want to use both of them. So the cosine rule, again, says the opposite side squared. So in this case, x squared is going to be equal to this squared plus this squared minus 2 times 12 times 5 times the cosine of the angle, which is 108 degrees. Okay, so I'm going to plug this into my calculator now because I can't really do all that in my head. So if I multiply by 12, multiply by 2, okay, 141, 69 minus nth gives me this. So I get that x squared is going to be 206.033. So x is going to be roughly 14.35. So that's how you find the other length then in this triangle. So that's using the sine rule and the cosine rule, okay? Yeah. So I'll do another one of them. So now, yeah, this one actually. So now I have 124. I have 37. I have 11.5. And what they want to know all the other lengths and all the other angles. So first of all, let's do this angle because it's quite easy. That's going to be 180 minus 37 minus 124. That's 56, so 23. Okay, so that's that. Now, this is another thing to look at in the sine rule and the cosine rule. It's like, what do you need? In the cosine rule, there's 4 things that you don't know. So basically, if you're using the cosine rule, you plug in 3 things that you do know to figure out 1 thing that you don't. Because here you have A, B, C, and the angle A. So excuse me, sorry. So there's 4 things you have in that formula. So there's only 1 thing that so if you want to use that formula, you need to know at least 3 things to be able to use it. So I need at least 2 sides and 1 angle, or I need the 3 sides. Do I have at least 2 sides? No, I don't. And therefore I can't use the cosine rule in this case. But I can use the sine rule. So the sine rule, so if I call this x and this y, I can say x over the sine of 37 is going to be 11.5 over the sine of 124. So this is going to be 13.8715. So x is going to be 13.8715 multiplied by the sine of 37. So x is going to be 8.35. Doing the exact same thing with the y, I know that y over the sine of 23 has to be equal to 13.8715. So y is going to be 13.8715 times the sine of 23. And then I get that y is going to be 5.42. So that's how you use the cos rule and the sine rule, and that's when you'd use them. So the sine rule, you need, so when to use it, you need two angles and two sides. So you need a minimum of either two angles and one side, or you need two sides and one angle. Here we have all three angles, so I have at least two angles, and then I have one side. So I just about have enough to figure out what the other sides are. And that's another thing to remember, that please don't forget, because it's very easy to, now that we're doing kind of harder stuff, to forget that, all three angles in a triangle will add up to 180. It's very easy to forget that, and a lot of people do, a lot of my students do. So it's one of the things just keep in your head, that and that's always a rule, and you almost always have to use it, okay? All right, so the next part is just a couple formulas in your log tables. I'm just going to write them down. Basically, the area of a triangle is equal to a half the base times the perpendicular height, where you have this. That's your base. Oh, don't know why that was that. That's your base and that's your height. You can also write, if I have the same triangle, if this is an angle C, this is the base and that's an length A, then this is actually A sine C. So remember, in the unit circle, this length here is always sine, this length here is always cos. So this is just A cos C, just for clarity. I'm not going to use that, but this is A sine C. So it's like you have your 1 here, you multiply by A, and I also multiply this by A. So in case you're wondering where the A sine came from. And now if I do the area, I'm going to get a half the base, which is B, times the perpendicular height, which is A sine C. So it's a half AB sine C. So that's in your log table. So that's another one that you could possibly use to find the area. Okay. Again, I've already kind of done this sort of stuff, so I'm just going to write it pretty fast. If you have a sector of a circle like this, where this is theta, this is R, this is the length, and the area is A, the length is simply equal to R times theta, where theta is in radians, and the area is going to be a half R squared theta. So remember, it's just simply equal to 2 pi R multiplied by theta over 2 pi, because that's like how much of the circle you have. Same thing here, it's just pi R squared times theta over 2 pi. And that's where these two formulas come from. So the length of the sector, so up here, or the area, that's just how you solve it. Okay? So hopefully that's not too bad. And the next thing I want to do, I'm going to do, I'll do one of these kind of 3D trigonometric problems, because I think they're quite hard. So what you have is, you have two things here. This is Q, this is R, this is P. So that's on the ground. Now you have a mast S up here, and it's attached to R like this, and you have another mast T up here, which is again attached to R like this. They're saying that they're vertical poles, which means these are our right angles, okay, with the ground. So just remember, this triangle here is a right angle. And so is this one. And you might say, well, how is that a right angle? It doesn't look like a right angle. Remember, this is on the ground. So RQ is on the ground, and this is a vertical mast up. So it's like if you look outside and you see a pole going straight up. anything along the ground is going to be perpendicular. So this is actually a right angle here. And this is a right angle here. Okay? So that's why these are they can be quite hard at times. Okay, so you have PR equals 8. These are both 10. PRQ is 120 degrees. So you have, and SR equals TR. So these two lengths are the same. So the mass coming down, okay? So first of all, I want you to calculate PQ. Okay. So very first thing, this length is 8. Hopefully that makes sense. The reason is because this triangle from here to here to here is congruent to this triangle, here to here to here. Why? Remember, you have your side, your angle, and your hypotenuse are all the same. So you have that the right angle, the hypotenuse, and the side here is the same. And therefore, if this is 8, this one also has to be 8. Okay? So to find PQ, so if I say PQ is equal to y, I can use the cosine rule there. So I can say y squared is going to be 8 squared plus 8 squared minus 2 times 8 times 8 times the cosine of 120. Okay? So I think the cosine of 120 is just minus a half. I'll just check that. Yep, minus a half. So this becomes 8 squared plus 8 squared. This is minus a half, so it becomes plus. The half cancels with the 2, so I'm just left with 8 squared. So I'm just left with 3 8 squared, which is going to be 172. And so y is going to be 13 point, I'm not sure. So you get 13.115 in meters. Okay, so hopefully that all makes sense. And then they want you to figure out what is SR in third form. So what is this length? X. So in third form, again, third form is just in square roots. Just leave it in square roots, so don't use decimal. So this is in decimal. Third form, I'll do it now in a second. I can say, well, x squared is going to be 10 squared plus 8 squared. So x squared is going to be 100 plus 64, 164. So x is going to be the square root of 164. Plug that into your calculator, but don't press the SD button. You'll get 2 root 41. So this is in third form. And don't forget to put meters on the end of it. And then finally, it asks to calculate the angle SRT. So SRT is this angle here. Okay? That's a very hard question. Now, what I'm going to do is I'm just going to redo the diagram here. So what I have is I have this, and I know this is the angle that I'm looking for. So it's A, I don't know. I know that both of them are length X. So this is 2 root 41. This is 2 root 41. So either I need to figure out what the angles are. So do I know what angle this is? No, I have no idea. Do I know what length that is? Yes, I do. This is length Y. And Y is 13.115. Okay. So now I can use the cosine rule on this. So I can say that 13.115 squared is going to be equal to 2 root 41 squared plus 2 root 41 squared minus 2 times root 41, 2 root 41, sorry, there should be an extra 2 here, times the cosine of a. Alright? So, 13.115 squared, that's equal to almost exactly 172. Okay, so I'll just leave it at that. This 2 root 41, that's going to be so x squared is this 164. So it's 164 times 2, so it's 328 minus 328 times the cosine of a. So I get that the cosine of a is equal to 328 minus 172, that's 28, so 156 divided by 328. So a is going to be the cos minus 1 of 156 over 328. So a is going to be shift cos 156 over 328. So it's 61.6 degrees. Okay, so yeah, that's that. And again, you can always look and say, okay, well, what is 2 root 41? 2 root 41 is equal to 12.8 meters. So you have 12.8 meters. So just to be clear, these numbers are very similar, which means you'd expect it to be close to an equilateral triangle, but not exactly. So you'd expect that we should get around 60, and we did. And therefore I can look at this and say, okay, that's a reasonable answer to get. All right. Okay. I think I'll leave that there for a minute. Okay. Very, very lastly, is the derivation of the cos a minus b, cos a plus b, sine a minus b, sine a plus b. These are quite hard. Okay. And so you can be asked these, and they do come up, and they are very, very, very hard if you do not know them. Okay. All right. So first of all, proving that cos a minus b is equal to cos a cos b plus sine a sine b. Okay. So what you do is, you do your unit circle, like this. You say, okay, let's say B is here. So again, I'm going to assume that B is smaller than A, just to make my life a little bit easier. Okay? So you have 2 points here. This angle here is going to be A. All right? And then we have our distance here. So remember, the radius is 1. So this point here is going to be cos B sine B. This point here is going to be cos A sine A. So first things first, this angle in here is A minus B. So I can use the cosine rule on this one. So what you're solving for D, the distance. And you're going to calculate it 2 different ways, and then that's how it'll come out. So you can say D squared is equal to 1 squared plus 1 squared minus 2 times 1 times 1 times the cosine of A minus B. So what I get is, I just simply get that D squared is going to be 2 minus 2 cos A minus B. So that's D squared. That's fine. Okay. The next way that I want to calculate it is just using the distance formula. So your distance formula, D, is basically just Pythagoras. Okay? So, okay, I probably shouldn't have drawn these the way I have, but yeah, I might just redraw it very quickly. So just imagine I had this. 1 point was there, and then 1 point was up here. If I asked you to calculate the distance between those 2 points, you'd say, this is D. You'd say, well, this is just going to be the height minus the other one, and then the length is going to be the x value minus the other x value. So that's like your distance formula. Okay, so your distance formula is just the square root, which again you would have done in junior cert, so hopefully this is fine. So it's the difference between the x values. So it's going to be cos A minus cos B squared plus sin A minus sin B squared. So it's always just a difference between the points. So now square both sides. If I square both sides, I'm going to get d squared. But d squared is equal to this thing. So I get that 2 minus 2 cos A minus B is going to be these things. So these things now I'm going to multiply out. So if I multiply out, I'm going to get cos squared A minus 2 cos A cos B plus cos squared B plus sin squared A minus 2 sin A cos B plus sin squared B. Great. Cos squared plus sin squared is 1. Cos squared plus sin squared is also 1. So I'm simply left with that this thing is going to be 2 minus 2 into cos A cos B plus sin A sin B. And therefore this thing has to be equal to this thing. And so we get that the cos of A minus B is equal to cos A cos B plus sin A sin B. Okay? Alright, so that's kind of that. And now it's very important that you know that this one comes first, because it's one of the things that, to prove the other formulas now, I'm going to use this one. Okay, so you need to know that this one comes first. Okay, why is that important? It's important because you do this one first, and therefore now we're going to prove the other formulas using this one. So in an exam, if they say, hey, prove this formula, you cannot use the other ones to prove it. Okay? That's not how it works. Okay? So you need to know which one comes first, and it's this one. And so if you're asked to prove this one, you have to prove from scratch. Okay? But now, if you were asked to prove cos A plus B is equal to cos A cos B minus sin A sin B, then it becomes much easier. Because basically this thing is equal to cos A minus B. And now this formula looks very much like this, where I'm just going to replace the B with a minus B. Plus sin A sin minus B. Okay? And this is equal to cos A plus B is equal to cos A. Cos of minus B is just the cos of B. Okay? This can be seen from, if I do my unit circle, if I go up 30 degrees or I go down 30 degrees, my x value is the same. And therefore, minus 30 degrees, so the cos of minus 30 and plus 30 are the same. Okay, because this is going to be the cos 30, this is cos of minus 30. So they're the same thing. So the cos of minus b is simply just the cos of b. Okay? This isn't true for sine. The sine of minus b is equal to minus sine b. And hopefully that was obvious, because this is the sine of 30. This is sine of minus 30. You can see that this is equal to minus sine of 30. So these lengths here are the same, but one is plus and then one is minus. Okay? So there we get this formula. All right. And that's that. The next one is just cos 2a. You basically just let b equal to a, and then just plug a and a in here, and that's it. You're done. So it's just cos squared minus sine squared, and that's it. The next one that's a little bit of a pain to do is the sine of a plus b. This, what you do is you grab your cos of a plus b, and what you do is, now again, if I just quickly draw them, so sine is this, cos is this. So it's always pi over 2 behind. Now, if I want to shift a graph to the right, I need to add the distance that I want to shift it. So I want to shift it pi over 2 to the right, and therefore I need to minus pi over 2. So if you get cos and just shift it by pi over 2, then that's going to shift it over. Okay? So I'm going to move it to the right by pi over 2, so they'll be the same. So you can change cos to sine by minusing pi over 2. Okay? And now I'm going to use the cos of a minus b formula, saying this is like my a, and this is my new b. So remember we just proved a second ago that the cos of a minus b prime, I'm just doing dashes just to distinguish them that they're different. The cos of a cos b plus sine a sine b. And I'm just going to plug these in. So this gives me the cos of a plus b cos of pi over 2 plus the sine of a plus b times the sine of times sine pi over 2, like this. Add that. No, sorry. I think. Wait. Is that fine or is that not fine? No, this is definitely not fine. Sorry, I'm just going to think for a couple of seconds because this is definitely wrong. What mistake have I made? I want to do sine a plus b using the cos. Yeah, this should be equal to sine a plus b, but I'm just getting sine a plus b equals a plus b. Yes, because this is just 0, you see. In case any of you are wondering why I'm... Yeah, because I'm just getting this sine a plus b equals sine a plus b. But I'm not actually proving what sine a plus b is. Okay. Okay, in my book here, it says that the proof actually isn't needed for this course, which feels a bit weird. I'm not sure if it does come up or not. Okay. I'm just going to do what the book does instead. So sorry, So everything here I said was fine, it's just that the proof doesn't come out. So if you do want to change cos into sine, you do just add pi over 2. Sorry, minus pi over 2. And then it will shift it, okay? But in the book here, it says you use cos of a minus b is cos a cos b plus sine a sine b. And then basically it says replace a with pi over 2 minus a on both sides. So if you do this, then I get that the cos of pi over 2 minus a minus b is equal to the cos of pi over 2 minus a cos b plus the sine of pi over 2 minus a cos b. So now this thing is the same thing as cos of a plus b minus pi over 2. So now I can get rid of the minus, because remember, the cos of a is equal to the cos of minus a. So I can just put a minus in front of all these here, and I get this. The same thing with the cos here. I can just change that to a minus pi over 2 times the cos of b. No, sorry, this actually isn't true now for the sine. So now when I change the sign, it's going to become a minus. Okay, so now remember when I said that if you do this, it becomes sine. So this will now become sine of a plus b equals. So again, if I minus pi over 2, it becomes sine. So I get sine a cos b. Now, what happens to sine? So if I grab sine, so sine is this one, and move it to the right by pi over 2, I actually get minus cos. So this is cos a cos b. Sorry, wait, no, that should be sine. Sorry, all of these should have been sine. And then that's it. Sine a plus b is just this. Grand. In case you're wondering, how did I know that this would have been cos, is because, again, sine is this. If I minus pi over 2, it goes to the right. So it becomes this, which is exactly the minus of cos. And then this would be the sine. Okay, so that's how I knew that this thing would become minus cos, and that's how the minus here is gotten rid of. And then finally, if you want sine of a minus b, well, sorry, penultimately really, minus b, you just plug in a minus b. So again, cos is unaffected, sine is affected, sorry. So yeah, basically this will stay the same because it's cos of b is the same thing as cos of minus b, but then here we get a minus sign that pops out. Okay. Now, very last thing, well, very last one of the proofs anyway, you'll probably be delighted to hear, is the tan of a plus b. And this is actually one that does come up, so you do need to know it. So showing that the tan of a plus b is the tan of a plus the tan of b all over 1 minus tan a tan b. That looks horrible. But remember, tan is equal to sine divided by cos. So it's sine of a plus b divided by cos of a plus b. Sine a plus b is going to be sine a cos b plus cos a sine b all over cos a cos b minus sine a sine b. So we have this. And now just look at what's happening. This one is going to be the cos a cos b. So how do I make cos a cos b into 1? I divide by cos a cos b. So divide the top and the bottom by cos a cos b. So the top, sine divided by cos is going to be tan a. Cos b divided by cos b is just 1. Cos a divided by cos a is 1. Sine b divided by sine cos b is going to be tan b. All over 1 minus tan a tan b. So remember, sine divided by cos is 10. And that's how you'd prove something like that. Okay? So hopefully that's all okay. Now, a couple of things that they'll want you to do now is basically they'll ask you in surd form what is something like the cos of 15. And this is when you'll have to remember your nice angles, which are 0, 30, 45, 60, and 90. Can I add or minus any of these? Because again, we've done cos A plus B, cos A minus B. We have formulas for that now. So can we do the cos of A plus or A minus to get 15? So just think about what ones we might use. We can do 45 minus 30, and we can do 60 minus 45. Makes absolutely no difference. I'm just going to choose 45 minus 30. So I can say the cos of 15 is the cos of 45 minus 30. If we go back to our cos A minus B formula, that's going to be cos A, so cos 45, cos 30 plus sine 45 sine 30, like that. The cos of 45, plug into your calculator, it'll be 1 over root 2. Cos of 30 is going to be root 3 over 2. Plus 1 over root 2 times a half, like this, okay? So this is just going to be root 3 plus 1 over, sorry, not 4. 2 root 2, sorry. So root 2 times 2 is 2 root 2. And that's it. Okay? So that's all you have to do. If it said something like the cos of 105, you'd say, oh, well, 105, that's going to be 60 plus 45. And then you'll do the cos of A plus B. And so on and so on. Okay? Another one they can ask, they could say, well, if the tan A plus B is 4, and we know tan B is 3, then what's tan A? That's just a tan A plus B formula. So you get 4 equals tan A, which is the thing we don't know, plus tan B, so plus 3, all over 1 minus tan A times tan B, that's 3 times tan B. Cross multiply, I get 4 minus 12 tan, sorry, that should be a tan A. Sorry, because tan B is equal to 3, so sorry, that's where the 3 came out and I plugged it in. Minus 12 tan A equals tan A plus 3. So I'm going to get 13 tan A equals 1. So tan A equals 1 over 13. And that's it. Okay. All right, is there anything else? Yes. Another thing they could say the cos of 2A is equal to 1 over 49. Basically find two values of cos A. So what could cos A basically be? The way you do this is you'd say, okay, well, cos 2A is equal to 1 minus tan squared A all over 1 plus tan squared A. So this is just one of your formulas in the formula tables. There's just tons and tons of them. So I'm not going to go through all of them. But basically, you always want to... so when you're ever doing this cos 2A and you want to find cos A or sin A or tan A, you always want to find either tan A, cos A, or sin A. Because using that, then you can figure it out. So it'll be obvious in a second as to why I can figure out cos A very easily once I have tan A. But that's basically what you want to do. So you have like cos 2A, cos 3A, cos 4A. You always want to find, okay, is there any one of those formulas that I can use that will give me just cos A, sin A, or tan A on its own? And so here, this is equal to 1 over 49. Again, cross multiply. So it's going to be 1 plus tan squared A is 1 minus 49 tan squared A. So I'm going to get that tan squared A is going to be equal to Wait, what? Yeah, that's 49. Okay. Yeah, I was getting worried there for a second. It should be 48 over 50. So you get that 10a is just going to be the square root of this. So it's root 24 over 25. Okay. Which is root 24 over 5. Now, you can draw a triangle out and say, okay, some right angle, this is your angle A. We had that the tan is root 24 over 5. So tan is the opposite over the adjacent. So if I want cos, I need to figure out what is the hypotenuse. So the hypotenuse, h, I can say h squared is going to be equal to root 24 squared, which is 24, plus 5 squared is equal to 49. So h is just equal to 7. So cos A is going to be 5 over 7, and they didn't ask for it, but if they did, you could also get that sin A would be minus 5 over 7. Sorry, root 24 over 7. Okay? Now, always just be careful when you're doing it. Back here, I assume that tan was positive. Okay? If tan happened to be negative, then you do the exact same working out and you'd basically get that it could be plus or minus this. Okay, that's all. Okay. So yeah, that's basically it. All right. I don't think there's anything else I want to cover in these questions. For the basics anyways, obviously, I don't know if any of you know, but my plan is to do some exam papers, which may or may not happen, but yeah, no, it's kind of, I'll cover the questions that come up in the exam papers and, you know, put emphasis on what ones come up and stuff like that. But yeah, but for now, I think that's probably enough. Okay, so yep, I think I'll leave it off there. So thank you very, very much for paying attention, and I think I'll leave it there. So thanks very much, and I'll talk to you next day.